Welcome to the Valve Studio. When I started doing high voltage design work here in the lab, I looked around for information about it. It's something I'd never done in my life. So, I found websites for vacuum tube design. I found YouTube channels. I found books. I found a lot of stuff. If you've done any of this kind of work, you know what I'm talking about. And a lot of people gravitate towards YouTube, and they'll find particular channels like Mr. Carlson's lab, D Labs, the Guitarologist, Tom Tech Test, Deep Blue Harp. These are all channels on YouTube that have a lot of different types of content, but nothing more really impressive in my mind than Uncle Doug. Uncle Doug renovates only guitar amplifiers, and he tries to explain the theory behind these guitar amplifiers, as well as go through rebuilding tips, new construction, renovation tips, basically anything you'd like to know about working on guitar amplifiers you can learn from Uncle Doug. So I decided, as a big fan of Uncle Doug, I was going to make him a gift, and we'll talk about that in a minute. But I've also been working, as you know, on this Hyatt machine, which is a Workbee 1010 CNC machine in my garage. And I built that basically to build these cabinets that I'm going to have up here on the top row of my electronics bench. And for these different variant speakers, and I need 6 identical ones. So I built this Workbee, and I went down this whole road of that type of thing. So I was ready to get started on these cabinets finally, after a long period of development time. But I decided let's make something smaller. Let's make something that is requires a little bit of accuracy, so I can test out the performance of my machine. And I figured, well, why don't I make Uncle Doug, a present while also using my machine to check out the machine from its accuracy standpoint, and also work on my burgeoning woodworking skills and my finishing skills and that type of thing. So I came up with a really good project. It is a box that sits on his bench that goes between these Variac and his amplifier that he's currently working on. And when you bring a guitar amplifier up, you want to slowly ramp up the voltage while monitoring the current to determine if there's any kind of shorts in the rectifier or any of the circuit itself, and to draw excessive current, because you don't want to burn out your power transformer. So a lot of people that work on these guitar amplifiers will have a light bulb. They inject a light bulb into the AC side so that it's a current limiter. And if there's a lot of current, the light bulb really illuminates a lot. If there's not, it just glows a little bit. But you don't have a sense of the current itself. You just have a sense of it's working or it's not. So I decided to make him a box that has a voltmeter and an ammeter and an outlet on it. So he plugs his box into his Variac. Then he'll plug his amplifier under test into the outlet, and then as he ramps up the voltage on the Variac, he can see what the actual voltage is, and you can actually see what the current is as well. So while I'm at it, Variacs are auto transformers. They don't isolate the line itself, the guitar amplifier. So I decided to also put an isolation transformer in this box. And I'm doing this because I have access to a bunch of scavenged power transformers that are ideal to use as isolation transformers, and this is a big transformer, so it's going to work just fine. So we're going to go ahead, and in this video, this is going to be pretty long. I'm going to go ahead and go through some of the design part of it using Fusion 360 and show you some CAD really quickly, CAD stuff, the CAM things, that type of thing. Then I'm going to go out and I'm going to show you some problems that I had on my Hyatt machine, my Workbee machine in the workshop, and what I ended up doing to correct those things. And then I'll show you the construction of the box, and then we will go through and test the box, and then we will be done here. We'll have a conclusion. So stay tuned. You know, this is a legitimate project, and maybe you'll get some ideas on how to make your own isolation voltmeter ammeter combination for your test bench. All right, I'm running a Fusion 360, and this is what the design's going to look like. It is made out of poplar that I get at Home Depot, and the poplar comes in two different sizes. I'm able to use like 5 1/4 inch or 6-inch poplar for certain pieces of it, but I got to use 8-inch for other pieces. But up in the front here, I have this. This can be a voltmeter. This is the ammeter, and then I have an outlet over here. And inside of here, I have some cleats to hold the bottom on. This is all going to be glued together. Then I have a cord hole in the back here that so that the cord can come out the back or out of the bottom, depending on how you want to run it. This enables you to run this thing all the way up against the back of your bench and not have the cord keep it from going all the way back, because then you can run the cord out of the bottom. I'm going to put some rubber feet on the bottom to hold it off of the base. And this is the isolation transformer. I've got access to a bunch of scavenged transformers, and this one is actually a very big one, which has two benefits. It doesn't make a lot of noise because it doesn't sing. It's heavy, so this box will sit firmly on your bench and not move around when you plug in your amplifier over here. And yeah, it's those things. So and it's free. You know, there's no need for this to go into landfill, particularly if we can use it for vintage vacuum tube guitar amplifier work. Okay, so the other thing is these are the cleats to hold the bottom on, and I'm going to use 1032 T-nuts stuck on the top of these, and we're going to screw it in with stainless steel screws from the bottom. That's what's going to hold it. So in order to do some work or change the fuse that's in here, take these screws out. Here's a finger hole that you can pull the bottom off and come in here and change the fuse. This particular ammeter is 3 amps, so I have a 3 amp fuse internal, and 3 amps is a relatively large amplifier for guitars. Okay, so I don't know if you're interested in the cam side of this, but over here on the cam side, we'll talk about like the front. Let me see here. How do we do this? We come over to here, and we're going to be on cam, and we want to look at the front and turn this off, and then we want to be on the front setup here. So here's like the cam thing. So I have this actually is 1/2 inch poplar, and I want the outlet to sit exactly flush and not be proud of this surface here. So if it's 1/2 inch, I had to make a pocket here for the actual receptacle, and then these are for the meter holes, and then there's a lip around the outside. Let me show you that part on the design. I did spend a fair amount of time on getting figuring out how to do the corners. So I have, the point of this project was to check out the accuracy of the machine and also make a present for Uncle Doug. So I wanted to check out, making fancy corners on boxes. So, my experience on this is very small. But I did figure out how to do this kind of elaborate corner, and I provisioned for a little bit of tolerance here, also for the glue to be in there for a place to go. And then you notice on the top, if I turn the top back on, the top rests inside of there. And what this really does is, if you look at the front, let me see here, if you look at the front doesn't have any seams of cabinetry on it, because the front and the back are all one piece, whereas the side shows you a little bit of the the cabinetry, and the bottom is actually a duplicate of the top. Just has an extra couple features on it. So knowing that, if we come back over here to manufacture, this is the cam portion of it. So if we go up here to the front, let me get this in the center here, and open this up, and we kind of regenerate all these tool paths. I'm using a 1/4 inch end mill for all this work, and I learned a lot about this piece of it, because this is the first real project I did with Fusion 360. So here's the pocket to do for the outlet. Here are the meter holes, and then this is for the actual receptacle to go out the front side. Here's a top lip that's there, and here's the finishing pass on it. Here's the bottom lip, and I learned how to use the ramp, and I also have some tabs here to hold it down. So this whole operation here takes 11 minutes. All right, so it worked out pretty well. You know, the design of it. It's a simple project, but you know, you got to start simple. So that we'll just leave it here, and I'll go ahead and show you what we did next. So I took all my CAM files, and I went out and machined out my pieces for the sides. And you can kind of see I'm using these clamps I got the idea from Marius Hornberger. And they are a cam design that uses copper pipes to hold down a cam underneath those handles, and then there's various blocks of that square part, and then those square pieces, those rectangles, and you can adjust the clamps to various widths. So we cut this out, and it went pretty well. I have some cam problems there, but we're going to cut out the outlet hole. And it's looking pretty good here. So then we're going to go around and do the perimeter. It turns out my little spacer there was hitting the spindle, which you'll see is a problem here in a minute. The machine powered right through this, but it kind of burned the thing in there. So now I'm running the outside perimeter. There, kind of hit that right there. Then I realized, oh, I got to move that. I got to take that part out and hope that we stay in place while we do this last little piece here. All right, so I cleaned all that stuff up. Here's my first dry fit of the front panel. I have my voltmeter. Pretty nice voltmeter. My ammeter here. This is 0 to 3 amps. And I'm using a black outlet receptacle so that it matches up with the meter. Here's my front panel. And in my haste to, okay, I'll tell you a little bit. Okay, here. So there's a little chip right here that when I was cutting out those tabs, I pulled the front panel apart. I was using a knife, and that turns out to not be too good, but just kind of test fitting this, everything went together really well. I was pleasantly surprised. We turn it over on the back side. You can kind of see that we don't have much tolerance there. It's designed at 1 millimeter, which makes it slide around a little bit, but that makes it fit together really well. And that little chip is hidden by the bezel, so I think we're good. So I put this together, and it fit together like crap. No, so I'll show you why. So we're going to measure some things here. This original design, the thickness was supposed to be 12 millimeters. Here are my 4 pieces, 2 sides, the front. And if we hold these together, what you're going to see, hopefully here, the camera works pretty crappy. We have a little bit of it's proud here for some reason. And we have the same problem, or even worse, on the other side. You can kind of see that. So I came in and measured these things. They're designed to be 6 millimeters. That one's 7.3 on one side and 6.18 on the other. That's quite a bit of variance. And I don't know if you're going to see this one or not, but this one's got similar type of problems with it. Alright, well, it's definitely not 6. And this one here is so off that you can actually visibly see that the heights are different. They're supposed to be the same. One is 5.85 and the other one's 6.8. So it's off by a millimeter, which is way off. Okay, so this was we started out a little bit too aggressive, and it turns out that part was actually warped. This piece isn't anywhere near. So what I got here are 4 pieces of scrap. My table isn't level, and it's not surfaced. So I went and surfaced the table with a fly cutter, and I made this test article. This has got all sorts of different X, Y, and Z dimensions. And with this, I was easily able to hold about 0.5 millimeter. All right, here's my second attempt at making these parts. I'm making the front panel here. This is after I leveled the bed, and I also planed my stock down to being about 12 millimeters. So here I'm doing the pocket for the outlet. And here's a meter hole, and I spent a lot of time working on clamping solutions. So I have those Marius clamps, and I also 3D printed some hold down clamps to get around the problem with warped boards, working with warped boards. And this particular tool is called a Mana Spectra bit. It's a 1/4 inch end mill, and you can really push this bit. You want to monitor the size of your chips, and either you can run pretty slow, but turns out you can speed them up and they fly through this. This was recorded at 10x speed. So I learned not to use a knife on these tabs. I do want to cut them out with a chisel. And this is actually one of the last parts I used these hold down clamps on. I've moved to using the painter's tape and super glue. That way you don't actually have to do these tabs, because everything stays down if you were to use that approach. There's a lot of videos on that. Then you don't have this post cleanup business. You have to take these little tab pieces off. And I was using an up cutter because I had my face was down on the surface, so I wanted the surface to look good. So you're going to have tear outs on the backside. I just took these off with a sandpaper. And it does look pretty good visually. Of course, we'll have to measure some stuff up and see how well we did. So I drew this out, and I'm going to measure some stuff here. First, I'm going to measure the diameter hole. I think it's about 70 millimeters. I did oversize it by 1 millimeter. And this dimension here turned out to be probably within 0.5 millimeter of the desired diameter. So there's a little bit of a more correction to do. And these particular things here, I measured this as well. And this was kind of critical, that outlet, because otherwise it kind of looks awkward when you actually put it in there. The meter has a flange on it to cover the holes. So this turns out to be 120, and it's actually exactly 120 all the way across. And then if we look at the real critical distance here is the these particular things here. So the width of my stock is actually about 12, and this ends up being about 6.2, it looks like. So the hold down clamp works pretty well, but I did move to using the tape. But before that, I actually went and I have an indicator here, and I pull my spindle out and push this down into the spindle hole, and then I took a matrix of values across my now flattened machine, and this is just an offset table, so these are relative numbers to each other. So my distance varies between 2 and 24. So I have a what is that? But it's probably about 0.2 millimeters of variance across the surface. Here's my first dry fit of the version 2 of this. You know, the second version of making these parts. I just kind of push it together. So it looks pretty good. The joints are really nice. I've got to put a little hole right here for the outlet because it's going to be held in from the front. Just going to take a look at that. So here I'm just kind of clamping it, and I have the meters actually in it as well as the outlet. I'm just kind of holding that in from the back. Here's the isolation transformer that I got. So back over here, you can kind of see a little bit of problems with the size there. And down here is going to be a little cleat, and there's a little bit of clearance there, which is good because the bottom is meant to come off, and the screws come up from the bottom. And there's the hole to put your thumb in or your finger in to pull the bottom back out again. There's plenty of clearance between the back of the meter and the isolation transformer, and the top fits on really nicely. And the joints are really tight, and there's not much work to do up here as well. There's a little bit of a issue with the heights here, but I could take that out with a sander. It fits together really nicely, and my piece of board stock for this second run wasn't warped at all. It looks great. So I took my parts over, and I figured let's go ahead and decorate them a little bit. So I'm going to put some schematics. You use this laser and burn some schematics into there. That first was a run where I was testing the power of the laser, and we're actually kind of committing now to burning those in. You'll see this a little bit more. Here's a clamping solution. I used a lot of clamps to hold this together, to pull all those joints together. I clamped it overnight. Alright, well here's the final dry fitting. I went ahead and sanded down all these joints along here. And it turns out that I had to do a little more work on my machine because some of these require that the Z height on my machine is to be very accurate, and also the spoiler board's got to be very flat. So I had a little bit of a problem here, so I ended up having to sand a lot of this, and because of that I was very scared to sand some of these things and not pull up too much of the graffiti on the top. And then I took 320 sandpaper and redid the top, and I was just a little hair too aggressive on the sanding, but this was never meant to be functional. It's more decorative. Here's the side. This is the fender baseman, and over here is the fender champ, and in the back it's just there's nothing on the back. Here's my 4 choices that I went and bought for my clear finish. I didn't want to stain it because I didn't want the graffiti to kind of fade away. I did some test runs on all these to kind of see how clear was, and I think I'm going to end up using this one here. This is a was this Rust-Oleum 2X Ultra matte clear, and I'll go ahead and show you my test pieces here. So, you know, I think that I sprayed this part up here with that, and you can kind of see that I wrote matte clear 2X, and then here's spar varnish down here. This one doesn't ever quite dry, so I'm not going to use that. Then over on this side I have the polyurethane that's down this edge. Then over here I'm using that deft, and then I have some other pieces. But you know, all in all, the matte clear finish looks good. It gives it just a little bit of a tint to it, and it kind of brings out the laser engraving. So we'll go with that. And then another thing, I watched some finishing YouTube videos, and there was a guy talking about spraying small enclosures like this, and he said it's very handy to go ahead and put it on Lazy Susan. So I had the mechanism, so I put this little Lazy Susan together, and then all I'm using to kind of hold it on there is that little piece of that drawer liner. All right, late last night I ended up putting about 4 coats of that clear coating on the outside. It's really beautiful. The color of the words really actually preserved pretty well. It's actually a little bit darker, which is what I was looking for. I got my voltmeter here, ammeter here, my outlet over here, and I have a 3-prong AC power cord running in over here. So let's see if I can take this apart with one hand. It's a little bit of a challenge, but there we go. Okay, we'll just kind of run over the components on the inside. So the AC power comes in here, it goes through a strain relief, runs over to here, and I got line, neutral, and ground. The ground passes right back through and goes over to the 3rd prong on the outlet. The neutral goes back up to the primary side of the transformer, and the primary side goes through a 3-amp fuse, which I believe this is probably a fast one. And I got this marked here so you don't put a larger fuse in the future. The secondary is running back up to the outlet and then also over to the voltmeter. The so-called the secondary line signal is running through the ammeter and then back over to the smaller pin on the 3-prong cord. So to put it back together, you just kind of pull those cords over there, and you got plenty of cords to work with. And you just put it back together. It goes back together really well, and there you have it. And then to hold it all together, I have 4 1032 screws that come up through the bottom and hook into those internal cleats that are inside of here. I am so pleased with how this turned out. It's really beautiful, really beautiful. All right, so I'm back here in the lab, and I'm going to test out my ISO volt ammeter. And acting as a load today, I have down here a 100-watt incandescent light bulb, and I got plugged into the one of the output. And then over here I'm running a Syncor AC power right, which is an auto transformer with a nice meter on here, and I can look at the line output as well as the current draw and look at leakage. We're not going to look at leakage, just the voltmeter and ammeter. All right, so let's got that thing on over there. Let's ramp this up to about 100. I'm sorry, we're going to ramp it up to 50 first. And I would think that about there is about 50. And our incandescent bulb is dimly glowing. We come over here, and this meter says I'm on the top scale, so we are about 46 volts. All right, let's ramp it up to 100 on the meter. That's about here. and our bulb is glowing a lot brighter, which is fair, and we're drawing more current. We are probably around, I think it's, I don't know, 0.6 amps. Then over here, this thing says about 90, maybe 91 volts. Alright, well, there's a little bit of a discrepancy here. I bought these meters, these analog power meters, off of a panel meter manufacturer in China. I got these two, and I got a couple other ones for about $18 a piece, which is fair. But you know, at that price, you're going to kind of sacrifice the accuracy. So let me see, who do I trust? This meter, or do I trust this one? This no doubt went through some calibration. However, it's probably at least 20 years old. We got 90 over there, and we're off by a 10. We're off by a factor of 10%, which is fairly significant. So I have brought in another meter to see who's true, and I have my Agilent DMM, and I got it wired into this outlet here. I mean this plug, and I'll just plug it in here, and we'll see who is lying. And that one says 101, and this is at 100. Actually, it's a little bit more, little more than that. And this one says we're at 91. So indeed, this is the culprit. This is not accurate, at least for voltage. This is accurate. So let's go over and look at current. Over here we got 0.2, 0.4, 0.6. No, that's not right. That's kind of weird. Actually, we're probably a little bit about half. I can't even tell what the units are on that meter. That's kind of interesting. Well, what do you say? 0.6 or so? Alright, that's 0.6 amps. We'll go over here and click us over to 1.5 amp scale, which is going to be this top one, and it's right here. So we are at, that's 0.8. 0.85. So over here, this is a little low. Again, the same question, who's the accurate one? So I have a clamp on ammeter here that goes down to 0 to 4 amps. We'll go ahead and hook on to one of the wires running our bulb, and we are at 0.75. So we don't know which one's accurate. Again, well, we have three conflicting numbers now. So I think what I'm going to end up doing is, I suspect this one is accurate as well. I'll go ahead and connect up an ammeter, but I'm not going to do that now. Well, that about wraps it up for today. Thank you, Uncle Doug, for all the things you've taught me. From my studio to yours, I hope you enjoy this present. And for the rest of you, thanks for watching. This is the Val Studio.